Okay, please don't get confused with programming. This one is only have two types, categorical and quantitative. Okay, so if you are not sure, right, very simple. One can count, one cannot count. Okay, one variable can do counting one variable cannot do counting one. I give an example. I have an age. Age is it quantitative or categorical? Can age count? Can, right? So that is going to be quantitative. Alright? For gender, male and female, is it quantitative? No, it is categorical. Got it? It is category because I got a category of male, I got a category of female. Got it? Let's say country is the same thing, right? I have in Singapore, I have UK, US. Those are categorical, right? Because there's a category, okay, of each of the countries. You understand? And so this is important. So in layman term, right, very simple. A quantitative variable is variable that can do mathematical calculation, computation on it. Categorical, you can't do mathematical computation on it. Yeah. Why do you need to know this? Very important, because you need to know what type of variable you have. Then you decide what data analysis approach to that problem, which I will show you later. Are you following me? Can Okay, good. So let's go a bit deeper. Okay, so next slide is go a bit deeper. When you say about categorical, you got two types. Okay, one is called ordinal, and one is called nominal. Okay, ordinal means what? Ordinal means it has order. Okay, so that's called ordinal, right? It has order. We'll give an example. If we first, second, third, fourth, fifth, do we have an order? You have, right? First will come before the second, right? And second comes before the third comes before the fourth, right? Remember? Yeah, so this is called ordinal. But a lot of people tend to convert some ordinal into numbers. Okay? It's not wrong, but normally first is not one. Why must first be one? First can be anything, right? But it must come before the second, and so forth. Okay? Another example of ordinal: temperature. Cold, medium, hot. So again, the cold will come before the medium will come before the hot, right? So that is again ordinal. They have certain order. Are you with me? Can I? So when there's things that no order, that's called nominal. Okay, I just give you an example already, right? Gender, is it ordinal or is it nominal? Nominal, correct. So some don't agree with me. Like some say gender is ordinal. Then you either you are very biased to the woman or very biased to the man. Right? You cannot say male comes before female, right? If I say male comes before female, that means I bias towards the man, right? If I say female comes before the male, right, then I bias to the woman, right? So either way, I also get cute, right? So I better don't get myself cute. So it should be more nominal in that sense, because you don't, the order don't matters. Alright, so same thing for the country, Singapore, UK, US, all those are nominal. Okay, you cannot say US better than UK better than Singapore. Okay, it doesn't make sense that way. Okay, so the orders are nominal. You got it? Okay. Quantitative very easy. It's either discrete or continuous. Okay, if you do not know, you map it to mathematics, right? Discrete means what? Integer value. Continuous are real numbers. Are you with me?
Real numbers.
Real number as in no. Real numbers is a bigger set than integer. Alright? But by the way, you all know what is real number and so on, right? Let me make sure I put some notation here. So for discrete, this is your integer value. For continuous, this is your real number. Okay? Discrete, integer value, continuous, real number. Okay, for example, just like I talked about age, right? Is age a discrete or continuous? Age, discrete or continuous? Age. How old you are, the age. Is it continuous? It's definitely quantitative, right? We have mentioned just now. Now I go a bit deeper. Is it discrete or is it continuous? Discrete, correct. Because it's integer value, right? Okay, how about height? How tall you are, the height is continuous, right? Because it's 1 point something, 2 point something, right? So these are continuous. Are you following me? No. Okay. I give you an example for height. Okay, example height is real, is continuous, is quantitative continuous variable, correct? Why? Because you look at the value you store inside. What do you store? You measure the person height, right? Either in probably in meters, right? If it's in meter, it's going to be what? 1.71, 1.82, 1.56. Those are the height, right? And all those are real numbers, correct? And real number then is called as a continuous quantitative value. Got it? Can age, that is how old you are, right? I also understand that you can put 41.2, 41.5, but normally we don't, right? Normally our age we count at 40 years old, 41 years old, 80 years old, 10 years old, and so on, right? So those are discrete because it's an integer value. Yeah, integer is like whole number, correct?
It's okay.
Integer, you think of integer as a number.
I don't mind.
Okay? Someone said whole number is not true. Whole number is natural number. Whole number is only have positive side only. Okay? It also includes a negative side. Okay? Integer also includes the negative side, also includes the zero. Got it? In mathematics, right? For those who do math notation, the sets of integer equals to a set of natural number, negative number, union zero, union a set of positive number. That's what the integer is all about. A set of natural number by its negative side plus union a zero and then union all the positive side. Okay, that's called integer. Got it? So whole number, have to be very careful. This whole number actually includes both the positive and negative side, also includes zero. That is called integer. Got it? Can Okay, good. Let's move on.
Union. He said something about union.
Okay, so that's how you break up. Okay, and then that is just give you some examples. Okay, I already given to you. So hopefully you understand this. So I will show you this. Okay. Next thing, very important. Next thing is that now we want to study the behavior. Okay, that's what statistics are about, right? We want to study the behavior of certain things inside a population. So in here you have two things. One thing it is a population. The whole universe, right, is called a population. Okay, let me be very clear first. This is very important for you to understand because when you do analysis, you need to know your scope of your study. Okay, I'll give you an example. I'm interested to find out how much Singaporeans are earning per month. Can you tell me what is the population? What the population means?
3 million.
Okay, 3 million. Okay. You have done economics, right? The number of population inside a country doesn't necessarily mean that they're earning active income, right? There are some like you're not earning income because you're a student, some retired, some is sick who cannot work, right? And some things like that, right? So when I'm interested to find out the salary for all the Singaporeans, right? What is my population? By population, of course, Singapore population is 5 million, but based on estimate, right, probably about 1.5 million or less than 2 million are earning active income. Okay, so that is the population. Okay, so if I want to find out this thing, right? Do you go and interview? Do you go ask 1.5 million Singaporeans, hey, how much you earn? You don't, right? So if you want, you can. That's called a population. Okay, but then you say, wow, ask 1.5 million people, well, very, very, very difficult to ask, right? So what I'm going to do? I will select a selective group. Okay, so that is called a sample. So I'll select a selective group, and that is called a sample. Okay, so Singapore may not be a good thing to ask. You say 1.5 million people still quite easy, right? Talk about China. You know how big is China? It's in billion one and in billion one. Are you going to interview the billions of people to find the average salary of they have? Yes, what? Thank you. Then you take probably few years to find that out. So, but by then the data is really obsolete already because after 3 years, right, the salary might have increased, right? You follow me? So that's not a good idea. The good idea is you select those people that you like to interview, and you actually select. Can you see? Sample is a subset of a population that you want to study. Yeah. So you select them probably in Singapore. You go. Okay. So also remember, you cannot select too small. You need to select big enough sample size to represent the population. You follow me?
No,
You don't have to select too much, you also don't select too much. For example, I want to find out the average money salary for Singaporeans, right? Do you go and ask only one person and conclude all Singaporeans earn that money? No, right? Let's say I ask let's say a cleaner asked her, how much you earn? She said 800 a month. So can I conclude see all Singaporeans earning 800 a month? I can't. If I go to the CEO of DBS, right? I ask him, hey, how much you earn? He tell you 300k per month. Oh, like that. Okay, probably 100k per month. Can you conclude Singaporeans are earning 100k per month? Also cannot. You follow me? So you need to choose the correct sample size. Okay. Now you ask me this question. Okay, that's all I'm going to ask also. Okay. So how big is good sample size? Okay, I can tell you the answer is you will learn this in after your term break. Your sample size must be at least 30. Okay, this is a good number. Okay, why is it a good number? It's because you will learn after the term break called central limit theorem. When your sample size is 30, it can approximate to a normal distribution, which I'll talk about it later. Yeah. So just remember this number 30. Okay, and you choose this 30, you have to choose correctly. Don't go and choose all of one occupation anyway. Don't go to the hospital and ask all the doctors of 30 doctors of their money paid. And that's not a good representation. You got what I'm talking about? So if I do 30, right, so what will I do? Maybe I choose 6 from the people working in the north, I choose 6 people working on the south, choose 6 from the east, choose 6 from the west, and probably choose the rest in the middle, with the central. Then I average it up, then I can use that to conclude the population. You got an idea? Got it? Yeah, so this is model. So that is what all the description that's it. Okay, so basically that's what I want to do. So I want to study the behavior of a population. Sometimes the size is too huge, I can't do it. So I need to select a sample. Question, how big is the sample? At least 30, must be minimum 30. Any sample that less than 30 may not be a good representation. Yeah? You will know this number later. Okay, trust me, you will know this number later. Okay, I just want to bring up front for you to tell you this. Yeah? And if you can do that, then you can use this sample. You can then use it to approximate the whole entire population. Got it? Got it? Can I? Later you will know why. Okay, I'll come to the end of the class. I will tell you why. Yeah? So in fact, the variance, right? You know, instead of calculate variance, you could use something slightly different in terms of population and in terms of sample. Yeah, we'll talk about that.
Does it look like banana to you?
So far, okay?
What does it look like?
Okay, quite straightforward.
A pipe, and then it's like,
Oh.
Okay, let me take a turn of this.
is it not? Does it not like?
Okay, so
Pipe.
example. Okay, so for example, MOM, right? Singapore Ministry of Manpower would like to do a survey of the Singaporean salary. Yeah. So what am I interested in? Okay. Of course, the salary. Okay. And who am I observing? Singaporean. That means Singaporean becomes your population. The money salary, it becomes your variable. Okay, you got a variable, right? Because you want to find out what is inside. Okay? Sample size, I told you, right? You cannot
I don't know.
talk to every Singaporean, right? You want to sample out some of them, right? In this case, how much I sample? 100. 100 is it okay? I think it's fine. Yeah? As I told you, sample size minimally must be 30. Anything less than 30 may not be statistically significant. Okay, so I'll talk about that towards the end. So this 100 is okay. And then after you do all your effort already, you say that, oh, finally I know the average. That's why MOM report, right? Average mean salary of Singaporeans is 5,000. Okay, so as I said, this is a mean. So it means that you can either earn above or below, depending on your income. Got it?
Can.
Yeah, so that's called observed value. So far, okay? Okay, good. Now, very important. Why am I stressing so much about type of data, right? It's because I need to know how to manipulate it. Can anyone tell me what type of data is this? Remember now there's 2 types, right? Categorical and categorical and quantitative, right? Then the categorical you have nominal and nominal, which is an order, and then ordinal, which is no ordinal. There's order, nominal has no order, right? Then for the other one, quantitative variable, you have discrete and continuous. Okay? Can you tell me what is this data? Very good. Nominal, correct. And what is it? Is it categorical or is it quantitative? Categorical. Very good. It is categorical nominal data. Okay, because the blood group, right? You don't say blood group A is better than blood group B or better than blood group O, right? It doesn't make sense. So that's what it is. So this is going to be a categorical nominal data. How do you process this data? Okay, very simple. You are going to plot. Okay, I leave this to you to read. At the end of the day, what you're going to do? I think this is what you have done in secondary school EMAX, right? Right? How many A's are there? How many AB? How many B? How many O? You put down the frequency, and then you plot out a bar chart. Correct? That's how we do. Okay, can you observe? When we talk about categorical data, when you plot the bar chart, right? You can see that each of them is represent one category. Okay, blood group A, blood group AB, blood group B, and blood group O. Each of these represent one category. Got it? And so what I did for you is this. I actually have convert this into Python for you already. Yeah. So and I'm going to upload this to for all of you. And this is the program I written. It do exactly the same thing. Okay, so don't worry, don't need to go and spend your time copying this one. Okay? I trust me. I have taken the pain to copy the whole entire AB of the blood group. I type in nicely for you already. Yeah, I saw them in the list. Okay, and finally, when I run my program, can you see? I drew up a bar chart for you. I say A, B, B, and O. Yeah, so you look at the bar chart, it looks the same. Okay, so that's why, as I said, in data analysis, the data that we have, right, is not only one or two. Okay, minimally it must be 30, right? To you already, right? A sample size must be minimum 30. In this case, okay. Can you tell me how big is this data? How many data points I have? How do you find? Are you going to count one by one? No, right? You're going to do what? You're going to do what? Length, right? Or p value, right? Okay, straight away I know how many blood group do I have? 50 of them. And is it good sample? Looks good. Okay, I told you a sample size must be minimum 30, right? So I got 50 here. That's okay. You see the power of doing mathematics using Python? If you want, if you want, of course you're going to spend all your time calculating how many A I have, how many AB I have, and so on. Then you calculate this one, correct? Okay, but then I actually write a program to automatically do all this for me. Yeah, so I don't care. I can feed whatever information there, automatically it will actually count for me. Yeah, and then I use that output and then analyze. Are you following me? Okay, so that is what it is. So remember, if you are given categorical nominal data, you're going to create a frequency table like this, and then when you plot your bar chart, it's going to be like this. Each of the bar is going to belong to one category. You got it? And good. Now, okay, let's look at this data. Can you tell me what is this data type? What is this? Okay, so you see, I want you to see all the link between all the slides. They are not individual, they are linked up together. Can you tell me what is the data type of this?
Oh.
What's the data? What's the type of variable? Am I storing all this information on?
Yeah.
Very good. Quantitative, continuous, right? Continuous, right? Why continuous? Because all have decimal point, all are real numbers, correct? My question to you is this: can I use the same method like what I've done, right? Each of the number I plot one bar. Then will that work? Will that work? Answer is not work. Okay? Can you tell me if I use the same method with this, right? Using this method of plotting the bar chart, right? Can you tell me how the bar chart look like? How the bar chart will look like based on this data? Can you visualize it? Can not? Can see or not? I'm going to tell you it will look like this. Okay, you have a very long line. So can you see what is the smallest number over here? Probably 7.6. I got two of them, right? So if you plot exactly, you use the same method as in the previous data set, then you have 7.6. Then you got two of them, right? So these two, right? Alright. Yeah. Now that you're going to look, probably the next one 7.6. After that, the next one probably 7.9 or 7.7. How many 7.7? Only one. 7.9. Only one. You follow me? And the other day, how you look like? You probably look something like this. A lot of time, the frequency is always one. You follow me? Because it's continuous. You understand what I'm talking about? So when you plot this graph, does it make sense to you? It don't make sense, right? It don't make sense because it becomes a flat. It becomes quite flat bar chart. Okay, what can I talk about this flat bar chart? Nothing much. Okay, so can you see now my techniques of me tabulating or analyzing this data is going to be different. What do I need to do? I think you have done it in your Emacs, right? Can you tell me what should I do with this sort of data? How should I plot a bar chart with this sort of data? Anyone? How? Okay, how we do it? We form what I call a class. Okay, I don't know whether you still remember this. We form a class, right? So we say that okay, maybe we group depending how many bar I want to see, and then I group them in the interval, right? 7.6 to 8.0, then one class. Okay, 8.1 to 8.5, one class. 8.6 to 9, one class, and so on. Yeah, and inside that class, what I do? I just need to count how many numbers that match this range of values, right? Then that becomes that. Okay? Now my question is that how do I, based on this diagram, right? How do I calculate the mean? How do I calculate this mean? Are you going to add up all the numbers you see before? Are you going to do this? Are you going to add up all these numbers, divide by 60? Why 60? Because I got 60 female, right? Okay, is this correct? No, no. Once you get this, I don't know whether you still remember, once you get this, how do I find the mean? The mean is always the midpoint of the class, right? Multiplied by the frequency. Okay, so that's why you can see there's a midpoint. The midpoint is basically take this plus this, divided by 2, I got a midpoint. Take the midpoint, multiplied by the frequency. Add the midpoint times the frequency, add the midpoint times the frequency, and so on, and then sum them up, divide by 60. Then I'll get the mean. Got it? Got it? Yeah. This one, does it make sense to calculate a mean? Can I calculate a mean here? Can or cannot? Can I calculate the mean for the bar chart? Can or cannot? Cannot. Why cannot? Because all the data are not numeric, all the data are categorical, right? So you can't do that. Are you guys with me? Okay, so you must remember what type of data you are given, how do you treat the data, and how do you plot the data is going to be very different. Whether is it continuous, whether is it categorical, and whether is it quantitative, so it's very different. Got it? Got it? Okay, good. Now, if you want to know how this is done, same thing. I have also provide you with the soft. You see, I have provide you with the program ready, and I have actually spent all my. Okay, for those of you who want to know how to do this, right? You go and see. Okay, I actually spend that time to type everything nicely for you. Like you don't really go and compare to check whether it's correct. Okay, so I type everything nicely for you. I determine the midpoint. And then I go to plot the graph. Yeah, so then when I run this program, you can see that this diagram and this diagram will look very similar, correct? Can you see? This graph and that bar chart, it looks the same, right? Looks very similar, except the color not the same. Okay, so after that it's the same, right? Got it? Okay? So that is how. Don't worry about this. I'll give you the source code for this. Yeah? So I don't expect you to memorize this, right? I don't expect you to understand this at this point. What I want to do is that towards the end of the semester, you should be able to do all this. Okay, the given data, you should be able to plot it, you should be able to analyze it. Yeah, so that's something I want all of you to do. Okay, so that is your type of data. Any questions at this point? Any question? Yeah. So that's one way. Okay, that's one way we handle the data. Okay, by plotting them into a bar chart. Okay. Another way is to use this called stem leaf plot. Okay, which I seldom do this. Okay, and this only can do it on the quantitative data. Okay, quantitative discrete data. Okay, remember just now what have we managed? We have done categorical non-nominal or categorical nominal data. We have done quantitative continuous data, right? The bar to bar chart. Okay. In order to do this one is going to be my quantitative discrete data. The data has to be discrete. Okay, it must be a real number. Okay? And how, okay, can you see? This is your what? Quantitative discrete data, right? And how do you plot the graph? Okay, we're going to use this thing called stem and leaf plot. Okay? And that whole idea is very simple one. Okay, the whole idea is very simple. You segregate the whole strings of numbers into two parts. The one that's in the tens, can you see these are in the tens, right? 50, 60, 70, 80, 90. Okay, this is called the stack. Okay, the right here is called the stack. Okay, let me write it for you. Okay, so this whole thing is called a stack.
Oh, for you.
Okay, and this whole thing here is called a leaf.
Color, no color.
What no color?
Okay, so that's how it looks like. Yeah. So for example, how come you have 5, then 2, 7? Because you have 52 and 57, right? So 5 is in the stem, which is in the tens. Then in the leaf, which is the ones, right? So there is 2 and 7. Okay. Similarly, how come this one is so long? Because I got 271, 172, 175, 77, 79. Okay, if you go up and then you check, you should be there. Are you guys with? Yeah, so again, to be frank, I seldom use this. Okay, so I seldom use it to plot. And normally, most of the data we deal with are mostly continuous. Yeah, not much data that we have is discrete. Okay, unless you talk about age and so on. Okay, other than that, most of data are continuous. Right? For example, temperature, your weight, your height, whatever. Okay, most of them are continuous. Got it? Can I? Okay. Question? Okay, good. If not, then I'm going to move on to the last. Okay, this one I think is a revision that I'm trying to move a little bit fast. Okay, so you're going to calculate your mean, your median, your mode, and your standard deviation. Okay, all this we have done it before. Huh? So, of course, I leave this for you to read. And what is the mean? Okay, mean in layman terms is called average. Right? Mean is average. Okay, you take up, you sum up everything, you divide by the total number of elements you have inside the data set. That's called a mean. Are you with me? Can I? Next. Okay, this is an example. How to calculate the mean? Very simple, right? You add up everything, then you divide by the number. Okay, let me show you some math notation. I think you should know how to do this. Okay?
Not color.
Wow. Then,
Okay, so for discrete data,
Jake from Adventure Time.
the mean
Okay.
is going to summation of all the observations divided by n. I equal to 1 to n. Okay, so what is this funny symbol means, right? It's called summation. That means sum up from x1, that means from first item to the next one all the way to the n. Add them up together, then divide the number of elements inside there. Okay, that's called mean. Got it? Can I? Then the next one is called median. Okay, can you tell me what is the difference between mean and median?
Median is the middle number.
Correct, good. Median is the middle number. That's correct. Yeah. But take note, before you can find median, okay, you need to do what? You need to arrange the number in ascending order or descending order. Doesn't matter. Are you with me? Remember, it must be sorted. Okay. To calculate mean, you don't need to sort. But to calculate median, you need to sort. All right. So now take a look at this. Wow, so long. Okay, I don't use so long. Okay, so give you an example. 10, 1, 10, 12, 80, 100, 1000. Okay, can you tell me what? Okay, I think it's too difficult. Okay, let's say 1, 10, 100,000. Four numbers, right? Can you tell me what's the mean? The mean is very simple, right? It's going to be 4 divided by 4, right? It's going to be 4, right? You understand what I'm talking about? Because 1,000 plus 100 is 1,000 and 1,100. Then that means this one you get 1,111. Correct? You add all these up, become 1,119. Right? Then you divide by 4. Oh, sorry, not all 4. So that means you will have probably this one is probably 2, right? 2, 8, like 3, 2, 7, 2, something. Okay, 2, 2, 7. Okay, let's say 2, 7, 8, for example. That is your mean. Okay? But what is your median? Median is your middle value. Middle value means what? You cancel the first one. See this? It's really the sorted number. You cancel the first one. You cancel the last one. Then as long as you cannot cancel anymore, now you have 2 elements, right? Over here, what you're going to do, you take the average of the 2. Okay, so you take 100 plus 10 divided by 2, you get 55. Can you see the great difference between the mean and the median? If the data are very far apart. Alright, so that's what it is. Got it?
So this median.
This median. The median is 55. Mean is this is mean. Mean is 200 plus. Got it? Can I? Okay, so if I have another 10,000, okay, I don't even want to bother to calculate the mean. So what I need to do? Can you see the median always like this one? Take the first one, take the last one, take away. Take the next one, and the next one. So what you left right here is right in the middle, then this is the median. Got it? Can I? Okay. That's what I did. So you arrange, just remember you have to arrange the number in sorted. Make sure it's sorted first before you can do this, okay? If it's not sorted, you're not going to work. Okay, you have to be sorted. Okay? So if you have 2 elements, that means when it's 16, right? You divide them. Right in the middle, there's 2 value, right? Then you need to do the average of the 2 values. And that's all. Got it?
No, got it. I don't know.
Okay, good.
Ultra pair.
The next one is the mode. Okay, what's the mode? Mode very simple. It's the if it occurs the most, that becomes the mode. Okay, give you an example.
Don't sound.
Take a look at this one. I got another. Okay. Take a look at this one. What is the mode of these numbers? Yes, correct. The mode is 1,000. Correct. Very good. Right, because mode the 1,000 appear 2 times, the rest appear only once. So the mode is 1,000. Okay. But what is the mode of this? A bit tricky. What is the mode of this? 1, 10, 100, 1,000, 1,000, 10. The mode is. Oh, sorry. Can you see? What is the mode? 1. Both the numbers, correct. This is called multi-mode. That means the mode is 10 and 1,000, correct. Okay, because it appears 2 times. Okay, 10 appears 2 times, 1,000 appears 2 times. Okay, always remember, mode is the highest frequency that the number occurs. Okay, so it can be, if your mode have 2 numbers, that's called multi-mode. Okay, called multi-mode. Okay, multi-mode means there is more than 1 number for the mode. Easy, right? Okay, so that is what you already covered in your secondary school maths. So let's move on. Okay, last one. Okay, let me skip this one for a while first. Okay, I'll come back to this later. Let me skip onto this standard deviation first. Okay, variance and standard deviation. Okay, so what this means is this. I have. Okay, let me simplify this a little. Okay, maybe let me simplify this. Okay, have you taken the picture for this one? I leave it here. Okay, so in case you want, you can take the picture. Okay, for example, I have 1, 2, 3, 4, 5. Right? So what is the mean? The mean is going to, you add out everything, you divide by 5, right? So the mean is going to be 3. Alright now? Because 1 plus 2 plus 3 plus 4 plus 5 is 15. 15 divided by 5 is 3. Okay? And when you draw a line like this is the mean. I want to see how far away, okay, that these sets of numbers are go away from 3. Okay, that means in this case, I want to know how far it is go away from 3 to the left and go away from 3 to the right.
Two.
And this is what I call standard deviation, SD. Okay, standard deviation, very simple, is a deviation from the mean. Always like this. Yeah? So if I move something away from my mean, must be equal length, equal length to the left and right. That movement is what I call standard deviation.
Wow.
Got it?
Now draw.
Question, how do I calculate
This
this?
is better.
The calculation is very simple. It's basically simple. Standard deviation equal to square root of summation xi minus x bar squared over n. Wow, very long, right? So the formula is here. It's the formula. Okay, can you see on top is summation x minus mu square over n. Why I do a square root? Because variance is sigma square. Standard deviation is the square root of variance. Okay? Now I want you to observe one thing. Can you see there's a formula that is very different? One is this, one is this. What's the difference? The difference is that this is a population variance. That means you remember just now I talked about population is the whole thing, right? You want to find the variance of the whole thing, you use the population variance. But most of the time we cannot get the population right. We use we use a sample, right? Then when you have a sample, all the value, then you use a sample variance. Alright, so in this case, you don't do an n, you do an n minus 1. That is the difference. Got it? What is this number tells you? This number tells you how much away from the mean it moved, one from the left and one from the right. So that's what I call standard deviation. Got it? Yeah, so the important thing is that I need you to know how to calculate this. Don't go and memorize this formula. The formula will give it to you, but you know how to use it and then know how to actually calculate it. Got it? Question so far? Yeah? Okay, the last thing which I skip out. Okay, so this is your standard deviation. Okay, can you see very troublesome? You have to first calculate the mean. Then what you do, you take every value minus away the mean, square it, add everything together, divide by n minus 1. After that, take a square root. Okay, that's how you get the answer, 16. So what this 16 means? This means that the mean is 67. If I move one step to my left and to my right, it will become 16 value away. Got it? Let me be clear. So means what? Means that the one is 67. Then one standard deviation away is basically means 16, right? So when I move to the left, I move 16 to the left. And I move 16 to the right. So when I move 16 to the left, what do I get? I get 51. Okay? And then when I move 16 to the right, I will get 83. And that's what I mean. That means from the mean, which is 67, if I move one standard deviation to the left and to the right, the value will go between 51 to 83. That's what it means. Got it? Yeah? Okay, so this one is pretty similar to your secondary school lessons. Yeah? Okay, and the last thing which I skipped just now, okay, the last thing which I skipped just now is this. Yeah? This one is pretty easy in a sense. Okay, let me draw you a diagram. Okay, and then you can break it. Okay, so you have a set of data. Okay, 1 to n. Okay, and what is the range? The range is to tell me what is this maximum value. Okay, I call it max. And what is the minimum value? I call this min. So range equal to the maximum value minus away the minimum value. You got it? Got it? Yeah. So that means depending, if you need a big note, this has to be sorted. That means you have to arrange in either ascending or descending, doesn't matter. Okay, so I normally prefer ascending. Yeah. So first you have to be sorted. Then you will see what is the smallest number and what's the biggest number. You take the biggest number, you minus the smallest number, that will give you a range. Got it? Just now I have covered something called median, right? Median is actually equal to Q2. That means right in the middle. And this is called Q2. Right? Remember how do I calculate median, right? I will just go from the left and right and keep coming down and then get in the middle value. Correct? That's what I'll do, right? That's called median. If you take the when you have a median, you cut the data set into two parts, right? Left and right, correct? Now? You get the middle value of this is called the lower quartile. You take the middle value of this is called upper quartile.
Yeah.
Right? And that's it. That is what all this is about. Okay? And then interquartile. Interquartile is equals to Q3 minus Q1. And that's what it does. Understand? Can so, for example, range, take the maximum minus the minimum. That is from where to where. That's your range. Q2 is also known as median. You cut right in the middle. When you slice right in the middle, you have two parts. The lower part you divide by 2, that's called a lower quartile range. The upper part you cut by half, that is called the upper quartile range. Okay, and take the difference between lower and upper quartile range, is what I call interquartile. Okay, and that's it. That's what all the notes is. Question? Yeah, so that's why I prefer to look at the diagram. Okay, once you understand this diagram, this is what this slide is talking about. Got it? So what I need you to do very, very simple. If you go back, okay, you try to find out. Now I have helped you to calculate two things, right? Calculate your mean and standard deviation, right? Okay. Maybe take this example, right? Can you tell me the range? Can you tell me the range? Can, but before that, what must I do? What must I do to this series of numbers? Sort it first, right? I need to sort it first, right? So what is the smallest number? 45.
45.
Correct? No? Then followed by 54. They correct me if I'm wrong. So 54, 56. Then what do I have? 54, 56,
67.
67. Okay.
78.
78.
78. Got 2.
70. 2 times of 78, 78, and 90.
Yeah.
Okay, so that's my number, right? Now, what is my range?
90 minus 45.
Thank you. Correct. 90 minus 45 and 45. That's the range. Correct.
Yeah.
Good. What is my median? 1, 2, 3, 4, 5, 6, 7. So I know the median is the fourth position. So it's 1, 2, 3, 4. So this is the median. Which is equal to 67. Okay. Once the median, can you see it cuts to two parts, right? Take note, based on what we define, we only calculate this one
Yeah.
and this one, right? So what is the middle value of this?
54.
54. This is Q1. This is Q1, right? Middle value, what is this?
78.
78 plus Q3. And what is the interquartile rate?
78 minus 54.
78 minus correct. Is it?
Yeah. Very easy.
Okay, good question. The way we calculate the first quartile rate, we exclude this value. Right? If you include this value, you are correct. Then if you include this value, then you are correct. Then the median will be 54 plus 56 by 2. Correct. Okay, but you exclude. Got it? Okay, so same thing. I have write a program for you also. Okay, so if you take a look at this, okay, I'm finishing already. I'll just sign. Okay.
So you're not finishing, you're finished.
Oh, I'm finished. Yes. You are very bad. So yeah, I will finish for the whole week. Yeah, correct.
Done.
Okay, you see? I don't have the mode, right? What's the mode? Principal mode is what? 78, right? So can you see? I calculate the median for you. Median is 67. The mode is 78. The range is 45. The Q1 is 55. Okay, good. Can you see at this point? Q1 is 55. Q3 is 78, right? It's slightly different. Okay, slightly different from this. This is 54, right? This is something I want you to know, okay? In maths, right? I mean the way we do it, we do not want to include this. Python programming, when you find the quartile range, right? Different, you would include this. If you include this, what is the answer? The Q1. Q1 is going to be
55.
average of these two together 55. So that's why I can see that's 55. Alright, yeah, so that's why I want you to do this. Take a math equation, whatever you do, calculate it, run your Python and make sure it's correct. If it's not correct, then you must ask yourself, why is it not correct? Okay? As I tell you, Python include this one inside. Okay, what you need to do very simple. You want to do exactly what we want, right? You need to type Python to exclude this one. Okay, let's look at the answer that is one. Alright? Okay, I'm going to upload this. I'm going to upload this for all of you. Okay, so that you can take a look. Don't worry about whether you know how to do it. Don't worry. Okay, at the end of the day, you should do this. Yeah.